Hello students, in this video we will continue with the introduction to exercise 2.3. So in the previous part of this video we understood what is a function and how a function is a subset of a relation. So you can define a relation between two functions by having them satisfy a particular criteria, but a function is a relation where the first element of the ordered pair has only one and one image. So it's not possible for a function to be defined if first element of the ordered pair has two corresponding values in the second element of the ordered pair. So continuing with that, we will start with definition 6. So from here on we will understand different types of functions. What are these type of functions called, how are they drawn on a Cartesian plane, and so on. So definition 6 says that a function which has either r or one of its subsets as its range is called a real valued function. So first type of function that we are studying here is a real valued function. So a real valued function is defined when the range of the function is a real value or any subset of it, be it natural number, be it integer. So anything that is a subset of the real number set, if that is the range of a function, then that function is called a real valued function. Okay, and further, if its domain is also r or subset of r, then it is called a real function. So these are two different terms. Okay, real valued function is purely dependent if the range is a real number set or a subset of a real number set, and real function is dependent if the domain as well as if the domain is also, so range plus domain, if range plus domain both are real valued or real number का subset या फिर real number का set है, then it's called a real function. So let's do example number 12 here now. So we are given that n is a set of natural number. Define a real valued function. So n is a subset of r, right? So we can say that this is a real valued function, and we are given a function from n to n, given that f of x is equals to 2x plus 1. So f of x is nothing but f of x is equal to y. So what you are given essentially is that y is equal to 2x plus 1. Okay, so using this we have to complete the table that is given to. It's pretty easy, right? So I'll just draw this table. So we are given here x and y. x का value हमको given है 1, 2, 3, 4, 5, 6 and 7, and we'll just fill the value of x in this equation to get the value of y. So if x is 1, y will be 3. If x is 2, y will be 4, and so on. Okay, so y is nothing but f of x. So f of, when x is equals to 1, the function can be written as f of 1, just like they have written f of 2, f of 3 and so on. Okay, so now let's deep dive into the type of functions and their graphs. So first हमने real valued function अभी पढ़ा, then all of the types that we are going to study now will be all are real valued functions. ठीक है, क्योंकि हम यहाँ पे non real valued वाले function से deal नहीं कर रहे हैं इस chapter में. So first type of real valued function is identity function. So name से ही पता चल रहा है identity function क्या है, कि what is the identity of something. If I am someone, my identity is me, right? I will define myself and say that this is my identity. Okay, so identity function is when y is equals to x. Okay, so we are given that let r be a set of real number, then the real valued function. So this function is defined as from r to r or by n to n or any subset of real functions, that it is defined by f of x is equal to x. That means x is equals to y. Okay, where x belongs to r. So this is a real valued function when x is equals to y. This function is known as identity function, and domain of this function is also r and range is also r, because if it is equal, then whatever I will give input I will get as output. So range, if it is r, then domain is also going to be r. So how you will draw this? So let's say this is 1, this is 2, this is 3, then 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. So if x is 1, y is also going to be 1. If x is 2, y is also going to be 2. If x is 3, y is also going to be 3. Similarly, 1 or minus 1, 2 or minus 2, 3 and minus 2. So once you draw it on a graph properly, you will get a straight line like this they have drawn here. So this is a graph of an identity function where x is equals to y at any point given on this line. Moving on to constant function. So again, the name suggests that no matter the change in value of x, the value of y will remain constant. So this function can be defined like this, that f of x is equals to any constant value no matter what we input. So f of 1 will also be c, f of 2 will also be c. So it doesn't change the value of x. So again, if let's say in my case I say that c is equals to 2, or okay, then f of x is equals to 2, then I don't care x का मेरा value क्या है. For all values of x, the value of y will be fixed at 2. So points क्या बनेंगे, 1 पे भी 2 है, 2 पे भी 2 है, 3 पे भी 2 है. तो this will be a straight line like this. Okay, moving on. So then third type of functions we have are polynomial functions. तो आइडेंटिटी फंक्शन में जब एफ ऑफ एक्स को हमने डिफ़ाइन किया था तो एक्स का पावर वॉज 1. ओके, एंड जब हमने कांस्टेंट फंक्शन में एफ ऑफ एक्स को डिफ़ाइन किया था तो एक्स का पावर वॉज 0. बट पॉलिनोमियल फंक्शन में एक्स का पावर विल बी ग्रेटर देन 1. ओके, सो एफ ऑफ एक्स कैन बी डिफाइंड इन दिस केस एज दिस इज़ एनी कॉन्स्टेंट वैल्यू, देन दिस इज़ द कोफिशिएंट ऑफ एक्स का पावर 1, देन एक्स का पावर 2 एंड सो ऑन. तो ये एक्स का पावर बट ग्रेटर देन 1 हमेशा रहेगा. सो मिनिमम क्राइटेरिया फॉर पॉलिनोमियल फंक्शन वुड बी इट्स ग्रेटर देन 1, बिकॉज 1 होगा तो हम उसको आइडेंटिटी फंक्शन बोल देंगे. ओके, सो एग्जाम्पल 13 करते हैं अभी. सो वी आर डिफाइंड अ फंक्शन from real number to real number. That means it is a real valued function, that y is equal to f of x is equal to x square and x belongs to R. So we have to complete the table that is given to us and we have to draw the graph. So let's complete the table, and by using this table only we will draw the graph of it. Okay, so हमें x का क्या क्या दिया है, -4, -3, -2, -1, 0, then 1, 2, 3 and 4. Okay, so for x is equal to -4, y will be 16, 9, 4, 1, 0, 1, 4, 9 and 16. Okay, because y is nothing but x ka square. Okay, so this is what the table looks like. Now if we fill these coefficients into the graph, my graph might not look that good, but just imagine that, okay, let's say this is 2, this is 4, this is 6, this is 8 and so on. Let's say up here we have 16, even though this is not 16. Then we have 1, 2, 3 and 4, 1, 2, 3 and 4, but of minus. So x0 पे y का वैल्यू इज़ 0, x1 पे y का वैल्यू इज़ 1 एंड x-1 पे भी y का वैल्यू इज़ 1, x2 पे y का वैल्यू इज़ 4 एंड -2 पे भी y का वैल्यू 4 है. देन 3 पे y का वैल्यू 9 है एंड 3 पे y का वैल्यू 9 है एंड 4 पे 16 चला जाएगा. तो ग्राफ इसका ऐसे बनेगा. ठीक है, तो यहाँ पे देखो इन्होंने अच्छे से बनाया हुआ है. सो दिस इज़ हाउ ग्राफ ऑफ अ पॉलिनोमियल विद एक्स का डिग्री +2 लुक्स लाइक. ठीक है, अब एक्स का डिग्री चेंज होने से या कोफिशिएंट चेंज होने से it will change the graph also. Moving on to example 14, here we will deal with x power 3. So यहाँ पे we are defined a function where f of x is equal to y is equal to x cube. ठीक है, अब इसका अगर हम टेबल बनाएं छोटा सा, let's say I'll use only 2 coefficients or maybe -2, -1, 0, 1 and -2. तो अगर x is -2, y will be 8, x is 1, y will be 1, 0, sorry, x is -2, then y will be -8 because the power of x is odd here, then 1 and 8. So this is how the table will fill. And if I draw it, let's say this is 8, this is -8, and this is minus 2, this is 2, this is 0, this is 1, 2, 1 and minus 2. So if I plot for x is equal to 1, y is equal to 1. If x is equal to 2, y is equal to 8. If x is equal to 1, y is equal to 1. And if x is equal to 2, y is equal to 8. So the graph is coming out to be somewhat like this. ओके क्या है, जब हम स्क्वायर का बना रहे थे तो दिस वाज लाइक दिस, बट अब ये यहाँ से शिफ्ट होके यहाँ चला गया. इट हैज़ चेंज्ड इस क्वाड्रेंट. वाई? बिकॉज क्योंकि एक्स का डिग्री ऑड है तो नेगेटिव साइंस विल बेयर द नेगेटिव साइन. पहले स्क्वायर में नेगेटिव साइन वाज टर्निंग इनटू पॉजिटिव. ओके, लेट्स डू एग्जाम्पल 15. एग्जाम्पल 15 में वी आर डिफाइंड रियल वैल्यूड फंक्शन फ्रॉम आर minus 0. So real numbers minus 0 to real numbers. So the domain range is real numbers and domain is r minus 0. And we are defined the function that f of x is equal to 1 by x. And x belongs to r minus 0. So we have to complete the table and we have to tell what is the domain and range of this function. So let's complete the table. For x, minus 2, minus 1.5, minus 1, minus 0.5, 0.25, 0.5, 1, 1.5 and 2. So y is what? Y is 1 by x. तो उसका हमें रेसिप्रोकल करना है और कुछ नहीं करना है. तो -2 का जब रेसिप्रोकल करेंगे तो वी विल गेट -0.5, 1.5 का -0.65, देन इसका -1 ही रहेगा, देन -2, 4, 2, 1 and 0.67, 0.5. Okay, so now we have to tell the range and domain of this function. We don't have to draw the graph. It's not asked us to draw the graph, but if you want to draw, you can just draw and you will see the graph looks like this. It doesn't meet at a point. So there are two sections of the graph. क्योंकि नेगेटिव वाले में अगर x का वैल्यू नेगेटिव है तो y का वैल्यू भी नेगेटिव क्वाड्रेंट में ही रह जाएगा, और अगर x का वैल्यू पॉजिटिव है तो y का वैल्यू भी पॉजिटिव क्वाड्रेंट में ही रह जाएगा. तो इसके लिए दीज आर नॉट मीटिंग अप एट एनी पॉइंट. ठीक है, सो लेट्स सी द रेंज एंड डोमेन ऑफ द फंक्शन. So it's pretty clear that domain is all the values except 0 because 1 by 0 is not defined. ठीक है, so domain is real numbers minus 0. एंड अगर रेंज की बात करें तो रेंज में डू यू थिंक कोई ऐसा नंबर होगा 1, 2 या कोई भी रियल नंबर जिसका अगर आप रेसिप्रोकल लोगे तो आपका आंसर 0 आएगा? नहीं, 0 आ ही नहीं सकता बिकॉज 1 by 0 इज़ नॉट डिफाइंड. अगर आप इसका रेसिप्रोकल लोगे तो 0 आता, बट दिस इज़ नॉट डिफाइंड, सो दिस इज़ नॉट पॉसिबल. सो रेंज इज़ ऑल्सो इक्वल्स टू r minus 0. Any value is possible except 0. Okay, then moving on to the modulus function, which is fifth type of function. Modulus. So modulus function is इक्वल टू लाइक जब हमने एफ ऑफ एक्स इज इक्वल टू एक्स स्क्वायर बनाया था तो चाहे एक्स का वैल्यू पॉजिटिव था या नेगेटिव था, फॉर द इक्वल वैल्यू जैसे 2 और -2 के लिए वाई का वैल्यू सेम था. ठीक है, सो इन दिस केस ऑल्सो दैट इज़ द केस. सो एफ ऑफ एक्स इज इक्वल टू इफ मॉड ऑफ एक्स, देन एक्स अगर 2 है तो वाई का वैल्यू 2 होगा, एक्स अगर -2 है तो भी वाई का वैल्यू 2 होगा. बेसिकली इट रिमूव्स द नेगेटिव साइन. ठीक है, तो इंस्टेड ऑफ जस्ट अ कर्व्ड वैल्यू यू विल गेट अ स्ट्रेट v बिकॉज आइडेंटिटी फंक्शन ही हो गया ना एक तरह से. y इज इक्वल टू मॉड ऑफ x, तो अगर x 1 है तो y भी 1 है, x 2 है तो y भी 2 है. इस फंक्शन में वो कर्व्ड क्रिएट हो रहा था बिकॉज इट वॉज स्क्वेयरिंग. तो 1 की वैल्यू पे तो 1 था, बट x2 पे उसका वैल्यू 4 हो जा रहा था y का. इन दिस केस x2 पे y का वैल्यू 2 ही रह रहा है, इसलिए इट्स जस्ट अ स्टीप v शेप्ड कर्व. Then we have a signum function. Signum function. So signum function is also nothing but इसमें कैसा है, this is another type of a constant function. ठीक है, इसमें आपको वैल्यू दिया रहेगा बट यू विल बी डिवाइडेड, द वैल्यू विल बी डिवाइडेड बेस्ड ऑन द साइन ऑफ एक्स. जैसे कांस्टेंट फंक्शन में इट वाज सिंपल कि कोई भी वैल्यू हो एक्स का नेगेटिव पॉजिटिव 0, आंसर विल बी सी. बट इन दिस केस it is defined in such a way that answer will be 1 if x is greater than 0, it will be 0 if x is 0, and -1 if x is less than 0. So how do we plot this? So it's easy to plot actually. So अगर x का value is greater than 0, then y will always be 1, positive 1. If x का value is 0, then y will be 0. This is 1 point only. And if x का value is negative, that is less than 0, then y will be -1. So this is how it is. But the important thing to remember is that you have to show this thing, like you have to show a circle here to indicate that this particular point is not included, that at x is equal to 0, y is 0, at x is equal to 0, y is not equal to 1. So you have to just indicate this by using this circle here. Then we have greatest integer function. Greatest integer function. So greatest integer function might be a new concept for you, but how this function is defined as that x का value अगर decimals में है, because real numbers also includes decimals, right? तो अगर x का value आपका decimals में है, then for a certain interval of the decimal, जैसे अगर 2 और 1 के बीच का मैं नंबर्स लूँ तो 1.5 भी रहेगा, 1.4 भी रहेगा, 1.6 भी रहेगा. तो इन सब नंबर्स के लिए वैल्यू विल बी greatest integer less than or equal to the number that is given. So greatest integer less than or equal to 1.6 is 1. Similarly 1.4 कोई ऐसा integer जो 1.4 से less हो या equal हो, it will be 1. ठीक है. So you have to remove the decimal part and you have to just take the before decimal part for this type of function. So this function can be plotted. I'll just explain. If this is 0 and if this is 1, this is 2, this is 3. So if you see that for any number that is between 1 and 0, be it 0.5, 0.6, the answer will be 0. So y will be 0 for that point. Okay, and for any number between 1 and 2, 1.2, 1.4, 1.3, so answer will always be 1. So y का वैल्यू हम ऐसे ड्रॉ करेंगे. सो 2 इज़ नॉट इंक्लूडेड हेयर, बिकॉज अगर 2 है वैल्यू तो y का वैल्यू 2 हो जाएगा. ठीक है. सो 2 पे हम यहाँ पे 2 से स्टार्ट करेंगे एंड अप टू 3 वी विल गो. देन सिमिलरली 3 और 4 के बीच में जितने भी नंबर्स हैं 3.5, 3.6, तो विल जस्ट रिमूव द डेसिमल एंड विल से that y at all these numbers is 3 except at 4. Similarly for all the negative values also. That is how the graph is drawn. Then we will just understand now that how we can do algebraic operations on two functions. अब तक हमने देखा कि functions होता क्या है, but let's say मेरे पास दो function है, that f of 1 of x is one type of function is 2x, and then I have another type of function which is 4x. So can I add these both functions and say that f of 1 plus f of 2 is equal to 6s? Is this even possible? So we will learn all of this now. So to understand the addition of real functions, so we can do the addition. Okay, so this is what is defined here. Okay, yeah. So this is what is defined here, that you can add two functions and you can denote it as f plus g of x is equal to f of x plus g of x. So what do they want to say here is that let's say I have a function f of x is equal to 2x and I have a function f of g of x is equals to 3x. Then it doesn't matter if I add them. Okay, let me just say that f of 1 will be 2 and f of g of 1 will also be, g of 1 will be 3. So it doesn't matter if I add them before. For example, if I add them before means that without putting the value of x, if I add them and then put the value of x, this will become, my new function will be 5x. And now if I put f of g, f plus g value at 1, I'll get 5. And if I add them separately in the initial, after getting the result individually, then also I'm getting 5. So this is what they try to say, that before putting the value of x, if you add the functions, will be equal to after putting the value of x. Okay, similarly subtraction also works, doesn't change anything. You can add the functions before putting the value of 1 or after putting the value of x, then it will be simple. Then multiplication, so between two functions multiplication and then multiplication of a function by a constant term. So if you have a function f of x, let's say again I'll take example of 2x. So if you multiply the function, let's say with 2 again, then 2 of f into x will be 4x. Okay, or after if you multiply, so let's say I put the value of x is equal to 1, then if I have f of 1 is equal to 2, and then if I multiply 2 times f1, I'll get 4, which will be similar to if I just multiply the function itself with 2 before and then put the value of x as 1, then I'll get the similar result. Okay, then multiplication of two functions is also will also work in the same way, that whether you multiply them before or after putting the value of x, the answer will be same. And then lastly, quotient, that is division. This will also work the same way given that g of x should not be 0. Given that g of x should not be 0 for any x. Okay, otherwise for that particular value of x, f upon g will not be defined. Just you need to just understand this a bit right now. When we will do exercise and in detail, you will get a better idea of what I'm trying to say here. Then let's do these two exercise examples and then we'll move on to the exercise. So we are given that f of x is equal to x square and g of x is equal to 2x plus 1. We are given that these are two real valued function. We have to find out the addition, subtraction, multiplication and division of this function. So it's pretty easy. So we know that f of g, अगर इनको add कर देंगे, will be equal to f of x plus g of x. So we just have to simply add it. This is the addition part. Now if I have to subtract, I can write that f of x minus g of x. So f of x is x square and minus g of x will give me this. Then if I have to multiply them both, that is also very simple. I just have to simply multiply. So x square multiplied by 2x plus 1, this will be 2x cube plus x square. Then f upon g of x, this will also be f of x divided by g upon x. So this will be x square upon 2x plus 1. But now you know that when the value of 2x plus 1 will be 0. So 2x plus 1 will be 0 at x is equal to minus 1 by 2. So it's important for you to write that x does not equal minus 1 by 2, because then this term will not be defined. Okay, moving on to example number 17. So here we are given f of x is under root x and g of x is x. Then these two functions defined were non-negative real numbers. Non-negative real numbers obviously comprises of whole numbers in a way. Then again we have to find all the functions. So f plus g of x will be under root x plus x. F minus g of f minus g will be under root x minus x. Then f g into x will be under root x multiplied by x. So this will be x3 by 2. Then f upon g of x will be under root x upon x. This will be x raised to power minus 1 by 2. Now again x should not be equal to 0. Why? Because even though हमने इसे न्यूमरेटर में शो कर दिया, essentially it is nothing but this. If x is equal to 0, this will be not defined. So we have to specify that. Moving on, we'll just solve the questions in upcoming videos, and then we will get a better idea of all different types of functions, how we can easily plot them and so on.